So we just looked at some reasons that Mercier and Sperber give to think that maybe we're not quite as smart as you might have thought that we were. And so what I want to do in this video is just elaborate on some of the reasons why that might be, and that will tee us up for thinking more carefully about not how we reason in general, but reason about what's morally right and wrong next week. So let's take a look at these two different systems of thought that some of you saw Peter Carruthers talking about in his discussion of human reasoning from a couple weeks ago. These can be brought in to help explain what's going on in some of the examples that Mercier and Sperber give as well. So here's this idea, it's this dual systems theory. It's this idea that we have kind of two different gears that we can put our mind in to think through stuff. So this first system is this way of thinking which is just fast and automatic and unconscious. It's the sort of thing that just happens below your level of awareness. Your mind is just chugging through ideas. If it's like a little computer, it's just taking in input, chugging through its little program, and then generating output without you even being aware of just what it's chugging through. So it gives you these fast, automatic answers, and these are the things that Mercier and Sperber point out to often have a certain kind of bias. The calculations that our little unconscious system one computer is using are often not calculations that always lead to the truth, though they might get things right more often than not. Then, in addition to that kind of unconscious quick processing, there's the system two that's slow and deliberate and conscious. This is the sort of thing that we often talk about when we talk about thinking. It's the sort of thinking that we're aware of, we're conscious of. But it turns out that it's actually really difficult to get people to switch in to their system two. This is the sort of thing that we spend years sending people to school to try and figure out how to do. It's what we do when we teach people how to do mathematics. We say, don't just come out with the first answer that comes to mind. Here's some procedures for you to just slow down and really work out slowly and deliberately and carefully. And by the way, sometimes it might require you to just write some things down on a piece of paper so you can keep track of them. It's going to be that slow and that deliberate. And it turns out, thinking like this is pretty darn effortful, and we're not really compelled to do it very often without something prodding us to do it. This is why we take so much effort to school one another to try and get us into figuring out what sort of procedures to really work through if you really want to get the right answer to a mathematics problem or to a formal logic problem in philosophy. And so what Mercier and Sperber point out is that oftentimes our quick little unconscious system one, that generates an answer right away, and it seems like it's the right answer to us, and the only way we'd be able to figure out that it's not the right answer is if we switch into system two and really ask ourselves, wait a second, put on the brakes. Is there some reason that my first answer might be wrong here? The problem is that by and large, we're just not really compelled to do that. We usually just kind of accept our system one answer and don't go back and say, whoa, hold up here, Andrew. Why don't you ask yourself, do you have good reason to think that's right? So let me give you a few more examples that Mercier and Sperber didn't have in their article, but it shows the difference between the system one and system two thinking. So here's a quick little math problem talking about math. So a bat and a ball together costs $1.10. The bat costs $1 more than the ball. So how much does the ball cost? Now, if you're like most people who look at this problem, you're going to say, oh, easy, the ball costs 10 cents. Ball costs 10 cents, the bat costs $1 more, so that makes sense. Together they would cost $1.10. So that's the answer that most people would give, but if you say, whoa, hold up, wait a second, let me think through here. Is there some reason to think that's wrong? You'll find out, it is wrong. The ball actually would have to cost 5 cents. because if the ball costs 5 cents, that means that the bat costs $1 more than the ball. So the bat would cost $1.05, and then together they would cost $1.10. That's the correct answer. But it just turns out that most people, they see that question, okay, the ball and the bat is $1.10. Well, and they've got 4 big ideas that are just really salient and available to them. You've got the bat, you've got the ball, and you've got the idea of $1, and you've got the idea of 10 cents. And so you figure, oh yeah, it must just be like those 4 ideas that are relevant. And it's saying that the bat costs $1 more. So we've got the bat and the dollar. Okay, so the bat must be $1. And then we've got the ball. Okay, how much does the ball cost? Well, I've only got one idea left. I already used the bat and the dollar and the ball, and so now the only idea left is the 10 cents. So the ball must cost 10 cents. Boom! That's the quick little automatic fast system 1 calculation that your mind seems to just chug through unconsciously. It just says, oh yeah, the ball must be 10 cents. There you go. But that answer is wrong. That little heuristic, that little algorithm that your unconscious processor is using gets you the wrong answer. And you're only going to discover the correct answer if you slow down, put on the brakes, and ask yourself, oh, wait a second, is the answer my quick system 1 is giving here, is that correct, or is there reasons to think that it's wrong? And again, the problem is, as Mercier and Sperber point out, most of the time, most of us just don't put on the brakes and we don't ask ourselves whether the answer that we're giving is incorrect. I'll give you one more example. So, which of the following events is more probable? So, first event is there's a massive flood somewhere in North America next year in which more than 1,000 people drown. And the second event is an earthquake that happens in California sometime next year. And that earthquake causes a flood in which more than 1,000 people drown. So which of those 2 events is most likely to happen? Again, if you're like most people, you're going to say, oh, well, the earthquake in California, that's more likely than like some random flood in North America next year. So that's your quick, unconscious, seems like the right answer response for most people. But again, if you slow down, put on the brakes, and think about it, you realize, oh yeah, it's just there's no way getting around it. That second event is much less likely than the first. After all, the first event is just saying, look, there's going to be a flood somewhere in North America. So it could be a flood in California. It could be a flood in Michigan. It could be a flood in Mexico City. And that flood, it could be the result of a number of things. Maybe the flood is the result of an earthquake. Maybe the flood is the result of levees breaking in Louisiana. Maybe the flood is the result of torrential rains in Tennessee. It could be any number of things. So we're just asking, look, could one of those things happen? What's the probability that somewhere, some flood caused by something might happen somewhere in North America? Whereas the second event, that's saying really specifically, yeah, but what's the probability that of all the floods that could happen, one of them is going to be caused by an earthquake, and it's going to happen not anywhere in North America, but it's going to happen in California. Well, the probability that something causes an earthquake or something causes a flood somewhere in North America is a lot higher than the probability that specifically an earthquake causes a flood and it causes it to happen in California. So clearly, the first event is way more probable than the second event. And yet, most people, when you ask them this question, they say, oh, yeah, that second event is more probable. Again, that seems to be because your fast system 1 just has this idea of earthquakes and the idea of California, and those are really available to you. You know, oh yeah, earthquakes, those happen in California. And so you're able to just really quickly glom onto this idea of an earthquake happening in California, whereas the first scenario, that's just asking about, well, floods in general in North America. There's not really a concrete idea you can grab onto there, and so you just say, oh yeah, an earthquake in California, that's an idea that I've got a good sense of. That must be the right answer. And yet it's wrong. Your system 1 deceives you again. But the only reason you would ever come to realize that that's wrong is if you put on the brakes and say, oh, I better go through my system 2 reasoning and really slowly and deliberately walk through what are the reasons for and against either one of these things being more probable. But again, because you've got the system 1 that just automatically chugs through the little problem and says, yeah, probably earthquake in California, you just go with that answer, and you do not ask yourself, is there some reason I might be wrong here? So this is the sort of thing that Mercier and Sperber call the Myside bias. That when you have an answer to a question that you think is correct, or that the people in your group think is correct, you tend not to really look for reasons why that answer might be wrong. You don't slip into system 2 and ask yourself, is there some reason that my initial answer here might be wrong? And this can kind of be a problem because that system 1 is always giving you really quick answers that are ready to hand. You could say, oh yeah, that seems like the right answer. And yet, it's really difficult for most humans to slip into system 2 and ask, yeah, but is it the right answer? What reasons, what evidence is there to think that that might actually be the wrong answer? But it's asking exactly those kinds of questions, which is what you need to do in order to solve problems like the ones I just gave you here, or the Wason card selection task that you saw in the reading by Mercier and Sperber. And that's the kind of skill that I try to get my philosophy students to do all the time. You want to always ask, whoa, slow down. What reasons are there to think that you might be wrong? It turns out humans are really, really terrible at doing that. Now, what Mercier and Sperber point out that we are actually pretty good at doing is switching into the system 2 when we need to fight someone else. So if someone comes along and they say, yo, your answer to this problem is actually wrong, or your group is wrong about this problem. So if I'm part of the anti-mask group on Facebook, and someone comes into our feed and says, hey guys, you're wrong, you need to wear masks, it's the best way to prevent COVID. Oh, well then, automatically we are really good at shifting into system 2 and saying, oh really? You're saying that I'm wrong? That actually people should wear masks? Well, here's 52 different reasons to think that actually I'm right and you're wrong. I am going to slowly and deliberately use my system 2 to think of every single reason I can for why I'm right and my group is right and you are wrong. So we're really good at shifting into the system 2 to come up with reasons why we're correct and other people are wrong if we get challenged in our beliefs. But we're really bad at shifting into that system 2 to come up with reasons to think that we're wrong and other people might be right instead. And that is that Myside bias that Mercier and Sperber point out. And it's the thing that makes all of those problems I gave you, that you can choose one to deal with in your assignment this week. It makes all of those problems really difficult because people get sucked in to this Myside bias of using system 2 only to examine why their own beliefs are correct and other people are wrong, but not so good at using it to ask whether they themselves might be wrong. When we come back after the break next week, we're going to take a look at how this dynamic between System 1 and System 2 and Myside Bias influences how we think about morality, what's morally right and morally wrong, and what reasons there are to think that some things are morally right and morally wrong. And we'll see again why it can be so difficult when people have disagreements about what's morally right and morally wrong for us to convince one another that, they might be incorrect about what's morally right or morally wrong. So we'll pick that up next week. I'll talk to you then.